In this video, we're going to be graphing factorized form. So this is when the quadratic has already been factorized for you. Okay, so this method will be useful for that. It will also be useful if you got something like y equals 3x squared plus 6x. So you could factorize this. They both have x in common and 3, so you can take out a common factor of 3x, and you can have x plus 2. So now it's in factorized form, so we can use the following method. So what we're going to do is finding the y-intercept. Now, because it's already factorized, the y-intercept occurs when x is equal to 0. So in this equation, we're just going to make x equal to 0, so y equals 2, x take 0, 0 take 2, 0 plus 4. And we know that y is equal to 2 times by negative 2. 0 take 2 is negative 2. 0 plus 4 is just 4. So times by 4. So therefore y is equal to 2 times negative 2, which is negative 4. Negative 4 times 4 is negative 16. Therefore the y-intercept is negative 16. Now the x-intercepts are going to occur when y is equal to 0. So if we sub this in up here, we're actually going to have 2x take 2, x plus 4 equals 0, and it's already factorized for us, so we can simply state that therefore x is equal to 2, or x is equal to negative 4. So therefore x-intercepts are 2 and negative 4. So we know our y-intercept, we know our x-intercepts. Now the equation of the axis of symmetry. So when it's in general form, you've been using x is equal to minus b over 2a. However, we don't have it in general form. So how can we find the axis of symmetry? Well, we know where the quadratic crosses the x-axis. So at 2 and negative 4. And so the axis of symmetry is going to occur halfway between these two x-intercepts. So the equation for the axis of symmetry is just going to be add them together and divide by 2. So it'll be 2 plus negative 4 divided by 2. So 2 plus negative 4 is 2 take 4, which is negative 2 over 2. Therefore x is equal to negative 2 divided by 2 is negative 1. So therefore axis of symmetry occurs at x is equal to negative 1. Now the coordinates of the vertex, we can find this by substituting in x is equal to negative 1 into y above. So in y we're going to have 2 lots of x, which is negative 1 take 2, and negative 1 plus 4. So it's going to be equal to 2. So negative 1 take 2 is negative 3. And negative 1 plus 4 is 3. So the y coordinate of the vertex is going to be 2 times negative 3, which is negative 6. Negative 6 times 3 is negative 18. So therefore the vertex occurs at negative 1, negative 18. So we know our vertex, we know our axis of symmetry, we know our x-intercepts and our y-intercept. So we can now just plot it. Now we don't quite have enough room, so we're going to have to change our scale. So we know that our vertex is all the way at negative 18. So we can go down in threes. So we can go down in negative 3, negative 6, negative 9, negative 12, negative 15, negative 18. And we can still go across in ones though. So this point here will be negative 1, negative 18. So we can mark our vertex, negative 1, negative 18, And we know our y-intercept is going to occur at negative 16. So if this is negative 15, this is negative 18, so negative 16 will be a third with the way down. So our y-intercept will be about here. So our negative 16 will be about here. Now, our x-intercepts are going to be at negative 4, so negative 1, 2, 3, 4. So we're going to have our one x-intercept is here at negative 4. And the other one's going to occur at positive 2. 1, 2. And halfway between negative 4 and 2 is going to be our axis of symmetry, which is at negative 1. So this is x equals negative 1, our axis of symmetry, our vertex, y-intercept, our x-intercept, our x-intercept, the y-intercept is negative 16. So now we're going to draw a nice smooth curve through all the points. So the last thing we need to do is label our graph. So our equation is y equals 2, x take 2, x plus 4. Thank you.